Notice, and this is the typical copyright, we continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, sections 1, 2, and 3. All 51 videos from those 3 sections have been published in their entirety on YouTube. Section 4, measurement. All 17 videos there are completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 videos are completed from that section. 5 have been published in their entirety on YouTube. Section 6, algebra. This is now the 17th of 22 videos, and hopefully by later in this month, September 2025, that will be finished. Section 7, relations, functions, and graphs, by October 2025. Section 8, geometry and trigonometry, by November 2025. And finally, Section 9, vectors and matrices, to be completed by the end of this year. Disclaimer, this schedule is just a projection and it is not to be interpreted as a contract with anybody. As I just said, Section 1, made up of 33 videos. They are all available, published in their entirety on YouTube, especially since this section forms the foundation on which the rest of the syllabus is based. So please make sure you look at these 33 videos and know them very well. A reminder here that you need to know the times tables 2 to 12, especially since calculators are not allowed in paper 1. As I just said, section 2, consumer arithmetic, all 12 of these videos from section 2 have been published on YouTube in their entirety. From section 3, sets, all 6 of these videos have been published on YouTube in their entirety. From section 4, measurement, these indicated in yellow here have been published on YouTube in their entirety. The others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. From section 5, statistics, this section has 18 videos. These 5 have been published in their entirety on YouTube as indicated. The others are only partially published on YouTube. Again, please see the direction in the description below for full access to these videos that are only partially published on YouTube. Right now, we are at section 6, algebra. This section has 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends these, shown on the right here. From those, please pay close attention to these last 2 down here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math examination. This is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tulsi. And over here is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. You can navigate that website by topics or years, where all questions for the last several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely it will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page of that website looks like. This is what it looks like. You would register first, and subsequent to that, sign in. Again, this is the URL of that website. That URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Just a reminder that this is the formula sheet that CXC provides for its math examination, CSEC math examination. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the syllabus, the full syllabus, this formula sheet is in the syllabus. This is the top part of that formula sheet. You do not need to learn these formulae, as this formula sheet will be provided during the examination, as I just said. And this is the below part of that same formula sheet. Please note that while you do not need to memorize these formulae here, you do need to know when and how to use them. Overview of Algebra Section 6. These first 4 objectives here have all been completed in these 4 videos here. Continuing with overview, these other 3 objectives have been completed in these videos over here. Objectives 5 to 7, overview, continued. These 4 objectives on this page, 8 to 11, have been completed in these 4 videos over here. Overview, continued. These 4 objectives over here have been completed in these 5 videos here. Objectives 12 to 15. Now we are at objective 16. Objective 16, which brings us to video 17. Solve quadratic equations algebraically. And then up to objective 21, we still have to cover those for section 6, algebra. And we will do those 5 objectives in these 5 videos here. So as I just said, we have completed up to video 16, which takes us to objective 15 in this section. These 5 are published in their entirety on YouTube, as indicated by these yellow boxes. These others are only partially published on YouTube. I am at video 17 now, and I will publish this one in its entirety on YouTube, since solving quadratic equations algebraically seem to be one of the most difficult things in algebra. So as I said, we are at objective 16, which says solve quadratic equations algebraically. And we are told to use the formula method, the factorization method, and completing the square methods. Now, we have looked at factorization before. We have looked at completing the square in the last video. So the only new thing here for you may be the formula method. In this video, we will consider 5 examples used in the last video of quadratic expressions for completing the square, but now converted into quadratic equations. In the sequence of, first of all, factorization, then we will look at formula, and finally, we will consider those same 5 examples by completing the square. And besides those 5, we will look at one more. So we are looking at 6 examples in this video. So this explanatory note here says 3 ways using the standard formula, by factorization, and by completing the square. For each example, we will begin with factorization, if possible, then by use of the standard formula, and that is followed finally by completing the square. In each example, we will get the same answer. So it's 3 ways of doing the same work. In the last 2 videos, we learned how to factorize quadratic expressions of the format ax squared plus bx plus c, as well as how to express those in the format a times x plus h squared plus k. If we add 0 on the right of the quadratic expression, it now becomes a quadratic equation. Example, ax squared plus bx plus c, that is the quadratic expression. If we add equals 0 here, we now have a quadratic equation. Example, 2x squared plus 3x plus 5 equals 0. So we will be using the same ordered examples as were used for completing the square in the last video. So first of all, we will begin with factorization. Now we know how to factorize this. We did this in the video previous to the last one. So we can factorize that, and we get these 2 as the factors equal to 0. Well, x plus 5 is equal to 0, or x minus 1 is equal to 0. Because if you multiply these 2 things and you get 0, one of them must be 0. We don't know which one. So we will work both of them. If we say x plus 5 is equal to 0, we can solve that and get x is equal to minus 5. And if we say x plus 1 is equal to 0, we can solve that and get x is equal to negative 1. Therefore, the solution to this quadratic equation is x is negative 5 or negative 1. That is solving that quadratic equation by factorization. Next, we will do the same thing, but this time we will use formula. The formula is this here, which is given on the examination formula sheet. So remember now, what is in front of this x squared here is a, if anything. If nothing is there, 1 is there. What is in the middle here is b, and what is at the end here is c. So all we have to do is substitute in this formula b, a, and c. B is there and A is there. So we substitute in this formula. B, we could see here, is plus 6, but we have a minus in the formula. So it will be minus 6 plus or minus the square root of b squared, which is 6 squared, minus 4 times A. Now, 1 is in front of that x squared, not 0. And c is 5 here. So when we substitute that, of course, a is 1 down here, so 2 times 1. We work that out, and we get negative 6 plus or minus the square root of 16 over 2, and we work that out. this here would work out to be plus or minus 4 over 2. So negative 6 plus or minus 4 over 2. And negative 6 minus 4, which would give you negative 10 over 2, which would give you negative 5. Or negative 6 plus 4 is negative 2 divided by 2, which would give you negative 1. So here are your answers again that we got from factorization. We now have them under the use of formula. So now let's do that same thing by using the concept of completing the square. Now we have done this before, so I'm not going to actually complete the square here. All I'm going to say, if you complete the square for that, you will get this. X plus 3 squared minus 4, that's that part on the left, is equal to 0. Now we have an equation here. We will solve that equation. We will remove 4 from that side and put it on the right hand side. And so we get x plus 3 squared is equal to 4. So we square root both sides. So we are able to get rid of this square from here. And the square root now appears on this side. So what we are left with is 3 plus x is equal to plus or minus the square root of 4. So note this plus or minus, we may tend to forget that. We may just say square root of 4 and say 2. So now we get rid of this 3 from this left-hand side, like that, by subtracting 3. And that appears as negative 3 on the right-hand side. And so what we have is x is equal to negative 3 minus 2, or negative 3 plus 2. And you work that out. Negative 3 minus 2 is negative 5, and negative 3 plus 2 is negative 1. As expected, all three methods give the same answers. So we are looking at 3 ways of solving a quadratic equation algebraically. Now, there is also a graphical method of solving this quadratic equation, but that is not included in this objective. Nevertheless, we will take a brief look at it. Now, this is a quadratic equation, but instead of putting it as 0, we put it as y. So y is equal to this, and we are going to pick points from x being 4 to x being negative 6, and then we will look at what happens when y is equal to 0. So these are the points. We substitute when x is 4, that equation there, then y is equal to 45, and so on. We plot the graph, and this is what we get. Those are the two axes. This point here is 0, 0. Coming down this y-axis, that point there is 0, which is really where the x-axis is. So now, this point here, when y is 0, x is negative 1. And this other point here, again, when y is 0, x is negative 5. So can you see the two answers there? X is negative 5 or negative 1 if we let y equal 0. Okay, on to example 2. That was just in passing to show you that there is a fourth way, and there is another section where we will deal with graphs. If you find this video useful and interesting, please like and share. You may also consider subscribing to this channel. Just to be clear, ax squared plus bx plus c, if you have an expression in that format, a is 2, b is 10, and c is 12. So let's look at example 2, factorization. We have seen this before. So we factorize this expression here, and we get this and that, those are the two factors, equal to 0, which means that one of them must be 0, but we don't know which one. So we will set either this one as 0 or that one as 0. And when we do that, we get 2x plus 6 is equal to 0. And if that happens, then x is equal to negative 3. We can solve that. Or if we say x plus 2 is equal to 0, then when we solve this, x is equal to negative 2. So the solution for this quadratic equation is that x is negative 3 or negative 2. Either one will work. Now by formula, this is the formula. By now we are familiar with that. It is given on the exam formula sheet. You know that this 2 here is A, this plus 10 is B, this plus 12 is C. So all we have to do is substitute in that formula. Where B is, you take it out and put in 10, and so on. So we have this, we simplify that. So negative 10 plus or minus the square root of 4 over 4. And that works out to be negative 10. The square root of 4 is 2, but there is a plus or minus there, over 4. So negative 10 minus 2 over 4, and negative 10 plus 2 over 4, and that will give us negative 3 or negative 2. That is by formula, which is the same answer as we got for factorization. Now let's look at completing the square. Same equation. We already did this, so I'm not going to do it again. We did it in the last video. Completing the square is equal to 0. Now we get rid of that negative half from this side. Comes on the right hand side, it becomes positive half. Enough space is not here, so we will complete this on the next slide and then return to this one. So we have to get rid of that 2 by dividing by 2 over on this side, which gives us a quarter. Then we now have to get rid of this square here by finding the square root on both sides. And that leaves us with this is equal to a half, plus or minus. If we use an LCM here of 2, we are going to get 2x plus 5 is equal to plus or minus 1. Remove that 5 from there and then the 2. So we remove the 5 and then we remove the 2. So we find that x is equal to, when you work this out, negative 5 minus 1 is negative 6 divided by 2, which would give us negative 3. And negative 5 plus 1 is negative 4 divided by 2 is equal to negative 2. So let's get back here. When completed on the previous slide, we got x is equal to negative 3 or negative 2. Well, as I said before, as expected, all three methods give the same answers. Example 3, and we have looked at this before in factorization and completing the square. So if you factorize this, you get that equal to 0. So if you multiply two things and you get 0, one of them must be 0. We don't know which one. So we will set each one alternately as 0. This one could be 0, or that one could be 0, and we will solve for both of them. 2x plus 2 is equal to 0. Then x is equal to negative 1. I don't have time to go through the details of that. By now, you should know that. And then x minus 4 is equal to 0. X is equal to 4. So from factorization, the solution to this quadratic equation is x is equal to 4 or negative 1. It could be either one. That is to say, if you substitute 4 in this quadratic equation here on the left-hand side, you will get 0 on the right-hand side. Or if you substitute negative 1 on the left-hand side here, you will get 0. Either one will give you 0. By formula, by now you know This is A, that is B, and that is C. So let's substitute. This is a minus B here, but B itself is minus 6. So minus minus 6 will give you a positive 6 there. You have to be very careful with these signs. And when you work that out, you get 6 plus or minus the square root of 100. That is to say, all of this under the square root sign will be 100. Still have to divide by 4. So 6 plus or minus 10 over 4. So we get 6 plus 10 over 4, which will give us 4, to be 16 divided by 4, or 6 minus 10 divided by 4, which would give us negative 4 divided by 4, which would give us negative 1. So again, we get the same answer as over here. Over here by factorization, over here by the use of formula. Now let's deal with completing the square. We have seen this before. Complete that square. We get this, which is equal to 0. So now we have to solve this equation. We get rid of this first, then, well, there is not enough space here, so we'll complete working it on the next slide and return to this slide. We need to get rid of that 2, which is multiplying here. So we divide over on this side. And then we need to get rid of this square on this side. So we square root both sides. And we get x minus 3 over 2 is equal to 5 over 2 plus or minus. And we work that out using LCM. So we get 2x minus 3 is equal to plus or minus 5. So 2x is equal to 3 plus 5. X is therefore equal to 3 plus 5 over 2, or 3 minus 5 over 2. And you work that out, and you get x is equal to 4, or negative 1. Let's go back to the original slide. X is equal to 4, or negative 1. By factorization, by use of formula, by completing the square. As expected, all three methods give the same answers. Example 4. Remember, we have looked at these examples already for factorization and completing the square. 6x squared minus 10x minus 10 is equal to 0. When we factorize this part here on the left, we get this multiplied by that is equal to 0. So remember, if you multiply two things and you get 0, one of them must be 0. So we will set this one here as 0, or that other one there as 0, and we will solve each one. When 3x plus 2 is equal to 0, then x is equal to negative 2/3. And if 2x minus 5 is equal to 0, then x is equal to 2.5. So the answer we get here from factorization is that x is 2.5, or negative 2/3. That is by factorization. All right, let's look at by formula. This is the formula. By now, you know that this 6 is A, this negative 11 is B, and this negative 10 is C. So all we need to do is substitute for B and so on. Now remember, this is a negative here already, but if you put in a negative 11 there, then minus negative 11 will actually give you a positive 11, and so on. We work through this part here under the square root sign, and we get the square root of 361. Square root of 361 is 19. So your answer is 11 plus or minus 19 over 12. And so when you work out the plus part, 11 plus 19 over 12, you get one answer. and you work out the negative part, 11 minus 19 over 12, you get another answer. So this first answer here is 2.5, and the next one here is negative 2/3, which is what we had over here. Factorization formula. Now, let's deal with completing the square. As I said, we have already done this work in the last video. So if we complete that square, we get this, which of course is equal to 0. So now you work this like an equation. You need to get rid of that there, then this here, then that there, and then we will get rid of the fractions by using LCM. So first step, we get rid of this from the left-hand side, and it is now on the right-hand side. Okay, we don't have enough space to complete this working on this side, so we use another slide, and then we will come back to this. So we need to get rid of that 6 from there. It's multiplying over on this side. You divide both sides. You get rid of the 6 from there, and it appears on this side. And then you work that part, and you get this. So now we need to get rid of this square here. So we find the square root on both sides, and that will leave us with x minus 11 over 12 is equal to 19 over 12 plus or minus. Use an LCM to get rid of this denominator here, and you get 12x minus 11 is equal to plus or minus 19, so that 12x is equal to 11, that is positive 11 plus or minus 19. So 11 plus 19 over 12, that's the plus part, and 11 minus 19 over 12, that's the minus part. And so you get 2.5 if you work this out, or you get negative 2/3 when you work that part out. So that's the answer using completing the square. As expected, no surprise here by now, all three methods would give the same answers. Let's look at example 5. This is the last example we are looking at with work that we have done before. Now, the thing about it is this cannot be factorized. So now you will see where that formula comes in, or even completing the square. What two factors of negative 16, that is to say 2 times negative 8 would give you negative 16. What two factors of negative 16 will add up to give negative 5? And there is no such two whole numbers. So we can solve it using factorization. So let's solve it using formula, and the formula never fails. By now you know that that is A, this negative 5 is B, this negative 8 is C. Substitute those in this formula, and you get this. You work that out. The part under the square root sign works out to be 89. This is 5 here. So 5 plus or minus the square root of 89 over 4. And the square root of 89 is 9.43. See the problem? Why you couldn't factorize it. But we can work with 9.43. And so we will add 5 to 9.43, divide by 4 and get one answer. Or we will subtract 9.43 from 5 and divide by 4 and get another answer. So the answers we get here are x is equal to 3.61 or negative 1.11. Now let's see if we were to substitute those numbers in this equation here. This is the left-hand side, and this is the right-hand side. If we were to substitute those numbers, let us say 3.61 to begin with, the left-hand side will work out to be 0, which is the right-hand side. Or if you use negative 1.11, that is the left-hand side on this side. When you work that out, you will get 0. So the left-hand side is equal to the right-hand side. Even though we couldn't solve this using factorization, we can test the answer from the formula to see if they are correct. Now, completing the square. We actually did this before. If we complete the square here, we get this, which is equal to 0. So now you know what we have to do. Get rid of that from the left-hand side, then get rid of that from the left-hand side, then get rid of that from the left-hand side, then get rid of the denominators. So we got rid of the negative 89 over 8 from the left-hand side to the right-hand side. So we don't have enough space to complete this working here, so we'll do it on the next slide and come back. So we need to get rid of that 2, which is multiplying. We divide both sides, and it appears here. This part here works out to 89 over 16. Now we need to get rid of the square, so we'll square root both sides. And that will leave us with this, because the square and the square root are gone, is equal to 9.43, the square root of that, over 4, which is the square root of 16, plus or minus. So we use the LCM of 4, and we get 4x minus 5 is equal to plus or minus 9.43. So that 4x is equal to positive 5 plus or minus 9.43. When we solve that, there's 4. So you add these two, 5 and 9.43, and divide by 4. Or you subtract 9.43 from 5 and divide by 4. And what do we get? 3.61 or negative 1.11. Those are the answers we got over here when we were using the formula. So let me get something clear. If you can use factorization and you're asked to use it, fine. If factorization doesn't work and you can use completing the square, if you are forced to use it, fine. But I think using this formula here is the easiest, especially since you don't have to remember the formula. It will be given on the formula sheet in the examination. So we get back here. As expected, these two methods, the use of formula and completing the square, we get the same answers. If you are given a choice, I would suggest you use of formula. If you have to use factorization, fine. And if the expression can be factorized and you have to use completing the square, you know how to do that. Okay, this is a new example. It is not one that you looked at before. And I am specifically using this for a reason. Solve negative 6x squared plus 12x minus 6. We can factorize that, and we get these two factors equal to 0, means one of them must be 0 since we don't know which one. Let's set each one as 0 at a time. And when you solve that, the first part, you get x is equal to 1. And you solve the second part, you get x is also equal to 1. And this is why I am using this specific example at this point. So x is equal to 1. We don't have two answers. Let's solve by formula. We substitute and we work that out. Minus 12 plus or minus 0. This part here works out to be 0. So we get negative 12 plus or minus 0 over negative 12, and we get 1 either way because the plus or minus is gone. So we get 1. Let's try completing the square. If we complete the square here, this is what we actually get. Negative 6 times x minus 1 squared. That's this here, completing the square. You can try it for yourself. Equal to 0. So now if we move that -6 over there and we divide 0 by that, you still get 0. So we want to find the square root over here and the square root of 0. No, we are not going to waste time with that. So x minus 1 is equal to 0. So x is equal to 1. So all three methods show that x is equal to 1. We only get one answer. And I will explain that in the next slide. As expected, these three methods give the same one answer. So you may be wondering why only the one solution and not the usual two that we got in the previous 5 examples. Well, maybe a graph will help us to understand this in the next slide. So if we set up the equation y is equal to -6x squared plus 12x minus 6, and we use various values for x, we will get the various values for y, corresponding values for y. We plot a graph, and this is what we get. Notice that this here is the x-axis, and this red line here is the y-axis, and this point is 0, 0. Notice this graph comes up from below here, goes up like that, barely touches that x-axis at this point, and it comes on back. The graph only touches the x-axis at one point, which is 1, 0. That is to say, when y is 0, x is 1. So if you put 0 here, where that y is, we will get x is 1, which is here, the only solution. When y is 0, x is 1. But at least we have a solution there. Now, if this graph had gone up and turned around somewhere here, it wouldn't have reached that x-axis, and then we would have no solution. Of course, if we had a graph coming from the top like this and goes like that, it would cut the x-axis at 2 points, so you would have two solutions. So you would have two solutions. But if the graph comes like that and it doesn't even touch the x-axis and it goes up back like that, then you would have no solution again. But we have a section that deals with graphs. We will discuss all of these things. But I'm just showing you this so you would know that this is why we only have one solution here, that the graph touches the x-axis at only one point. In summary, solve quadratic equations algebraically. We can use factorization like this. We can use formula like that. And we could complete the square like this. For the time being, we will stay with those three. Later on, we will learn about using graphs to solve not just quadratic equations, but to solve simultaneous equations. In this video, we reused questions 1 and 5 of the quadratic expression examples that we used in the last presentation. Objective 15, on completing the squares, but now expressed as quadratic equations. Example 6 is totally new, to make a point with the graph that you could have one answer, and even later on, you could even have no answer. As expected, these three methods give the same answers if you could use factorization as well. And that will be all for this objective. So that brings us to the end of objective 16, solve quadratic equations algebraically. We looked at factorization first, then use of formula, and then completing the square. And we briefly looked at use of graphs, even though that isn't required in this section. So that brings us to the end of video 17 based on objective 16 in section 6.